Okay, in this video, we're going to take a look at a linear demand. Okay, so sometimes we draw them as lines, sometimes we draw them as curves. Usually, we just draw them as lines for convenience sake. But I just want to show you something. So two things we're going to show in this video is we're going to show that slope is not, and the second thing we're going to show is we're going to show the relationship between elasticity along a line. Okay, so first of all, okay, so let's just draw the whole line in this case. So we're going to go, let's see, 1, 2, 3, 4, 5. Okay, so I will try my best to keep this straight enough that it works for this problem. So this is our line. This is our demand curve. I'm drawing it as a straight line so that we can do something with it. And first of all, let's ask ourselves, well, what's the slope of this line? Okay, so it's our slope. So we can use these two endpoints. So we can use these endpoints. Well, it goes, remember, without using any kind of formula, slope is, well, rise over run, right? So it goes down 5 and it goes over 15. Okay, so it goes down 5 over 15 to go from the one endpoint to the other endpoint. And so we end up with our slope is negative 1/3. All right, you're going to see in a second that's not our elasticity. In fact, the elasticity is different throughout this curve. So let's go ahead and make a table on the side of elasticity, and then we'll get a chance to see how elasticity is different. Okay, so we're going to put in here our price, our quantity, revenue, and then we're going to use the midpoint method. And so to do the midpoint method, so we're going to use our midpoint method. I want to actually put the elasticity here, but you will be able to see by just looking at it whether it's elastic, unit elastic, or inelastic. Okay, so we got our percentage change in quantity, and we got our percentage change in price. Okay, and remember that, and we're going to use the midpoint method to calculate this thing. Okay, so I'm not going to show all the calculations just because that would be too time consuming, but you can go ahead and, as an exercise, you could double check them. So first, when the price is 5, quantity is 0. Of course, if quantity is 0, then revenue is 0. Okay, we can't calculate a percentage change because we didn't change from anywhere yet. Okay, and then when the price is 4, now the quantity is 3. Okay, so this would be 3. That would be there. Okay, so this is 4. So now our revenue is 12. Okay, and how much did our quantity change? Well, our quantity changed by 1. Oh, sorry. Our quantity changed by 3. It went from 0 to 3, so it changed by 3, and we're dividing by half of the midpoint. So half of 0 plus 3, which is the midpoint, dividing by 1.5. So our quantity increased by 200% using this midpoint method. And then how much did our price change? Well, it went from 5 to 4, so it changed by 1. It went down by 1, and we're dividing by the midpoint. So the midpoint of 5 and 4 is 4.5. So again, I believe it comes out to negative 22%. So we can see here it's clearly elastic because the quantity went up when the price went down by 22%, the quantity went up by 200%. So it's almost 10 times, right? So the elasticity will be like something like 9. So anyway, you can see clearly that this is elastic. And so when the price is 3, they want to buy 6. So we get up to 18, right? And then when the price is, and so then that one we went from 3 to 6. So we're doing 3 divided by the midpoint, which is 4.5. So we end up, well, the quantity went up 66%, and the price went down by 1. And we divide that, so from 4 to 3, divided by the midpoint, which is 3.5. And so we get negative 29%. And we can see it's still elastic, right? It's still elastic. And then we keep going. So 2, by the time we get to 2, we get 2 to the quantity goes to 9, and this is also 18, and we get this in between. Okay, so from 2 to 9, we get this situation. So we get 40%, and this is 40%, and then we keep going. 12, so the revenue is now going down. And if we go to the calculation, you'll see this is 29%, and this is minus 66%, and then finally going on. Okay, so some of these calculations, if you're if you're a little worried about them, one suggestion would be just pause the video and try to see if you can get the numbers that match with what I'm doing. I just didn't want to make the video super long by calculating every part. So we're going to find something happens here. So here, if we look at the top part, here we're elastic because the change in price is small compared to the change in quantity. Here we're inelastic because again, now here the change in price is big, change in quantity is small. And in the middle, we get to be unit elastic. And so actually, this happens on every graph that's linear, every demand curve that's linear. There's a part that is elastic at the top. There's a part that's inelastic at the bottom. And somewhere in the exact center is unit elastic, okay? And we can also see that the revenue was going up when it was elastic, and then the revenue starts to fall when it's inelastic, right? And actually, we can draw our revenue curve from this. So revenue, remember, is price times quantity. And here we can draw a revenue curve on this. So using the same quantities, and here's our revenue. And so our revenue is just a graph of all those areas of revenue. And so we're going to find that our revenue does like this. So it also matches that. So the center that's unit elastic will be the top of the curve of revenue. And in between, it's going to go up, and then it's going to go back down. It's going to have this quadratic shape. Okay, so two things from this video. One is that slope is not elasticity. And the second thing is that along a straight line demand curve, the elasticity is constantly changing, right? It still has this relationship of, there's a relationship between elasticity of a change and the revenue, but along a demand curve, elasticity is constantly changing. And again, why is this happening? Well, it's happening because the numbers you divide by are changing, right? So when we go from a high price, we're at a very low quantity, very high price. So when you start from a low number, then a percentage change being big is pretty easy, right? And we start with a high number, the percentage change being small is likely because you're dividing by some big stuff, right? So anyways, we see that there's this relationship. I won't really emphasize this so much, but it is still something important to understand and to know.